So hi, in this video, we're going to solve the particular problem from probability, which appear in J-Main 1999. It's a very interesting problem. So first try to understand the problem. Here says that we have an integer m and n that is chosen at random from an integer set 1 to 100, right? Such that the number generated by 7 to the power m plus 7 to the power n is divisible by 5. So let's go ahead and solve this problem. So now notice carefully, right? Here we have to consider an event, right? So we consider first let A be the event that 7 to the power m plus 7 to the power n is divisible by 5 while m belongs to, or maybe m and n actually belongs to the set. Let's write down properly. So here m comma n belongs to the set 1, 2, and so on up to 100 only. Okay, that's it. Now, what is the condition, right? That number is divisible by 5. So therefore, we know that unit digit must be 0 or 5. That's why we'll say that it is equivalent to saying that the unit digit of 7 to the power m plus 7 to the power n must be 0 or 5. So therefore, we have to analyze the concept that what is the chances, right? If I multiply 7 multiple number of times and add them together as 7 to the power m and 7 to the power n form, what will be the possibilities in the unit digit? Okay, that's it. To observe that, first we consider that power of m. So go ahead. So if I observe that 7 to the power 1, what will be the unit digit? That's 7. What will be the unit digit for 7 square? That is 49. So therefore it's 9. 7 cube, you can say 343, and we obtain, first we have to multiply the unit digit, right? So 7 into 9, it is 63, and then 6 plus something. So that will be the process. Here I am writing only the unit digit. And if I try to write 7 to the power 4, it is again 1, right? If I go ahead and write 7 to the power 5, what happened? If I multiply that unit digit as 1 multiplied by 7, again the unit digit is 7. 7 to the power 6, the unit digit will be repeated again 9. 7 to the power 7, the unit digit will be 3, and obviously 7 to the power 8, the unit digit will come back again as 1. Right? 7 into 320. Okay, that's it. And the same thing will prevail continuously, that we can observe, right? So therefore, we can easily conclude that from here, one important information that says that, right, that 7 to the power 4k plus 1, the corresponding unit digit will be 7. The unit digit for 7 to the power 4k plus 2, that unit digit will be 9. 7 to the power 4k plus 3, it's definitely equal to 3. And the unit digit for 7 to the power 4k plus 4, that's obviously 1. And here, k starts from 0. So 0, 1, and so on. Why? Because if I put k equal to 0, then 7 to the power 1 came, right? So that's why this rule is satisfied, right? Only for k equal to 0. If we go ahead, right, and take some other general representation, based on that, maybe the k value will change. So this is the first observation we make. So What do you observe? Observe that the unit digit, right? Unit digit of 7 to the power m or 7 to the power n for any values of mn must be either 1 or 3 or 9 or maybe 7 or maybe 3. For what values? See that already that 1 happens for 4k plus 4, 9 happens for 4k plus 2, and so on, right? Now we need to find out that unit digit of 7 to the power m and 7 to the power 9, right, will be 0, right? That's the condition. So we can easily say that 7 to the power m plus 7 to the power n must have unit digit as 0 if there are few cases, right? What are the first cases? That if m is equal to 4k plus 2, n is equal to obviously 4k plus 4. Now, why I say that, right? Because see that when m is equal to 4k plus 2, what is the unit digit? That's 9. 4k plus 4, the unit digit is 1. Now, if I add them together, 9 plus 1, that's 0, right? And that's it. Now, we cannot get that unit digit as 5 because 5 is not possible, right? Because 7, 3, 9, 1, right? Whatever the way we added, right? 7 plus 9, 16, 7 plus 1, 8, 9 plus 3, 12. So therefore, any other combination we make, we should not get 5. So therefore, only the 0 is the possibility. Okay. Now, mn is there. Also, m can be 4k plus 4. This is actually the repeated. We just interchange the values of m and n. So therefore, it is 4k plus 2. Okay. Let's go ahead. If I go ahead and consider that m is equal to, we get it as 7 now, right? So 4k plus 4 and 2 is considered. So now 7 and 3. So therefore m is equal to 4k plus 1 and n must be 4k plus 3. Okay, that's one more condition. And we can say that, right, that m is equal to 4k plus 3 and n is equal to 4k plus 1. That's it. So these are the cases for which 7 to the power m and 7 to the power n is there. Now, here observe that this m and n, right, mass belongs to 1 to 100. So our job is to find out that using this general representation 4k plus 2, right, when k stands from 0 to 1 2 3 and all that, how many integers are there in such form so that if that it lies between 1 to 100. So that's our job now to find out. So let's go ahead and find out that only. So as I said, here, first we consider that how many numbers and everything is possible in this particular case. So first we consider that 4k plus 1 in that particular form, we should get a integer that should be 100. So if I calculate, right, it says that k is less than equal to 99 divided by 4, right? So that's definitely approximately k less than equal to 99 by 4. It will be 24.75. Okay, that's it. So in this case, right, our k starts from 0, 1, and so on into a 24 because we have that k is a integer, right? So therefore, we get total set of 25 integer of the form 4k plus 1 between 4k between 1 to 100. I'm sorry. of the form 4k plus 1, and that is actually between 1 to 100 that we obtain. Let's go ahead and test for the other one. So if it is 4k plus 2 and I consider that's less than equal to 100, which imply that k is less than equal to 98 divided by 4, and 98 by 4 is approximately equal to 24.5. So here also, right, we can easily say that k is equal to 0 and dot dot to 1 dot dot to 24. Again, we get 25 integer. If I consider that 4k plus 3, that's less than equal to 100. So that's imply that k is less than equal to 97 divided by 4, which is definitely equal to 24.25. So here also it's implied that k goes from 0 to 24, and if this case also we get 25 integer of the form 4k plus 2, right? Last one, that 4k plus 4, that's less than equal to 100. So here also we get that k is less than equal to 96 divided by 4, that is equal to 24. So obviously in this case my k goes from 0 to 24, and we get 25 integer in this particular form, right? That's it. So therefore, we can conclude that final statement in this case, that every case, right, we are getting, right, 25 integer of the form 4k plus 1 plus 4k plus 2 plus 4k plus 3 and 4k plus 4 between 1 to 100. So every case is whatever we had discussed in that beginning, right? That every case is we are having 25 integer. Now let's go ahead and go to the original problem. So just now we complete our analysis stating that that M and N, right? If you are writing this form, you can choose any 24 plus 25 divided by 2, expect goes from 0 to 1 to 24. So therefore, that if it is, we can choose M and N, right? So for every case, for every case, M and N can be chosen in 25 place.
Like, comment, and subscribe. Like, comment, and subscribe.